Hey everyone, and welcome to The Explainer. I am incredibly pumped that you're here today because we are setting off on a truly mind-bending journey. We're going to dive deep into the geometric roots of physical reality itself. We'll be walking through some groundbreaking analysis that fundamentally reshapes how we understand the basic building blocks of the universe. We're moving away from the idea of static objects and diving straight into the pure mechanics of change. So get ready because this is going to totally shift your perspective.
Okay, let's dive right into this. We have to start with a massive core mystery. If we live in a deterministic universe, a universe that follows strict, unbreakable rules, why does it often look like it makes random choices? Why do paths seemingly fork, creating multiple possible futures from a single present state? It's a question that has literally haunted physics for a century.
Section 1, the paradox of the node. To really wrap our heads around this, imagine waking up at a crossroads with total amnesia. You know exactly where you are. You're standing right in the middle of a converging vertex, a node. But because you have absolutely no memory of the road you just walked down to get there, you can't predict which road you're supposed to take next. You've lost your momentum. You've lost your history.
Think about it like this. If we define our reality by the node state, meaning we are looking strictly at our current position, we get a totally ambiguous future. The system literally seems to forget the history of how it arrived there, and that creates this powerful illusion of randomness. But if we switch gears and look at the edge state, defining our state as the combination of our previous position and our current position, suddenly the future is guaranteed. The path forward becomes crystal clear.
Now, what's absolutely fascinating here is this concept of artificial indeterminacy. The source material proposes that the fork in the road leading to those unpredictable futures, it isn't actually a fundamental physics problem at all. It's a measurement problem. It's an absolute illusion that gets created when we measure a beautifully deterministic system at the wrong granularity, completely erasing its history in the process.
So, how do we fix this? Well, that brings us to Section 2, the edge lift. This is the detective's missing clue. To solve the mystery, we have to fundamentally change how we observe the system. We've got to stop looking at the isolated, instantaneous node and instead elevate our perspective.
The definition of this edge lift is just beautifully simple. The true state of physical reality isn't just where you are right now. The true state is an ordered pair. It's the combination of where you just were and where you are now. It basically requires holding on to that tiny, immediate piece of the past to accurately define the present. And when you make this shift, the results are staggering. First off, it restores the predecessor coordinate, which gives the system its history back. Second, the evolution of the system becomes strict bijection. Now, in math terms, that just means every input has exactly one perfectly reversible output. And third, that apparent fork in the road we talked about earlier entirely disappears. By just adding this one single piece of history, the path forward is suddenly perfectly clear and completely deterministic. But here is where it gets wild. The research shows that when we project our view from this perfectly reversible edge back down to a simple node, we permanently discard exactly one bit of information at the merge. The system literally forgets which of the two histories it came from. And this single bit erasure is massive. It implies that the second law of thermodynamics, the creation of entropy, isn't just some statistical tendency of a bunch of particles. It's a strict bookkeeping identity occurring at the very most fundamental level of geometry.
Let's move to Section 3, building the jet tower, and see how this pure geometric trick organically creates the physics we observe and measure every single day.
It stacks up neatly like a ladder. Step 1 is J0, the zeroth lift, which is simply position. That's our node. Step 2 is J1, the first lift to the edge, which gives us velocity and, astonishingly enough, mass. Step 3 is J2, the second lift, which encompasses 3 consecutive positions, giving us acceleration. So the derived physical observables we study in physics, they aren't separate, disconnected things. They stack up perfectly as successive lifts of our geometric perspective.
To really hammer this home, listen to this direct quote from the source framework. The apparent fork at a convergent vertex completely disappears once the predecessor coordinate is restored. This isn't just some neat math trick, folks. Resolving this node paradox elegantly unites geometry and physics, proving that ambiguity only exists when our measurement is incomplete. Now you might be wondering, okay, where's the hard proof? Well, prepare yourself for Section 4, the smoking gun. The researchers ran the data, and this computational proof is what cracks the case wide open. To test their theory, they used a mathematical operator called the discrete second difference, or delta squared. Put simply, this is just our mathematical tool for measuring acceleration across discrete, step-by-step changes in a system. And this brilliantly illustrates the breakthrough in the data. The researchers ran delta squared over a 6-bit Dubrine sequence, which is essentially a highly complex loop designed to test every possible combination. When they measured acceleration at the node level, it was a chaotic mess. It yielded 32 highly ambiguous sets over 32 nodes, totally multivalued and unpredictable. But when measured on the edge, it produced exactly 0 ambiguous sets over 64 edges. The acceleration was perfectly single-valued.
Let's summarize what this undeniable evidence is telling us. On the node, acceleration is multi-valued, and the state suffers from a 1-bit hash erasure, creating this huge illusion of randomness. But on the edge, acceleration is perfectly single-valued, maintaining a bijective, completely reversible fold. The data outright confirms it. Mass and acceleration functionally live on the edge, not on the node.
Which brings us to Section 5, Physics Native to the Edge. What does all of this mean for our fundamental understanding of physical reality? Honestly, it changes the entire paradigm of how we view the universe. So the crucial point is this. Mass and acceleration are not disparate, random phenomena. They are successive rungs on the exact same identical edge state. Mass and physical change aren't just arbitrary forces glued onto the universe after the fact. No, they are native, mathematically unavoidable functions of the edge primitive itself. They emerge organically just by observing the universe at the correct, history-preserving depth. Which leaves us with this final provocative thought. If something as fundamental as mass and acceleration can be decoded, shown to be an artifact of simply looking at the wrong geometric layer, what else in physics is waiting to be edge-lifted? What other deep mysteries of the universe are really just illusions of a lost history? I hope this explainer has completely flipped how you look at the physical world. Stay curious, keep questioning the baseline, and I will catch you next time.